Okay, let's start. Rakshita,
Yes, sir.
have you joined yesterday's and day before yesterday's session?
Sorry, sir. I'm unaware of the class timings.
Are you in the group or outside the group?
In the group only, sir.
And then,
So, sir, I'm not did it intentionally. I really don't know the timings, and there is a class. I'm not unaware of the class timings, sir. If
what was the class times that we are handling from day one?
7,
And then, if it would have been the evening, I would have informed in the group, right?
yes.
And then, what is the problem?
No, sir, no problem. But I'm unaware of the timings, sir. Really, not it intentionally. ನಿಜವಾಗ್ಲೂ ನಂಗೆ ಗೊತ್ತಿರಲಿಲ್ಲ ಸರ್ ಕ್ಲಾಸ್ ಇದೆ ಅಂತಾನೆ.
Okay, tell me what is sentinel policy?
But I need to go through it. Yesterday's I didn't join.
Even though when you're not joined, you should be able to tell what we covered in previous session, correct? Forget about you wantedly you joined or you did not join, you have some reasons, that is fine.
No, sir. Really, I don't know the timings.
No,
Class.
yeah, that is what I'm saying. You leave about your for you are not knowing that you have you don't know the class timings. You leave that. Okay, we're able to understand.
Yes, sir.
Now tell me what is sentinel policy that I covered on yesterday's and day before yesterday's session. What is state locking? Rakshita.
Sir, I need to go through both concepts, sir.
Okay. Now tell me what concept you are aware.
In Kubernetes, I know.
Okay, what are the concepts you are aware in Kubernetes?
I know. I know Kubernetes architecture and stateful set, daemon set, and difference between deployment and um,
Rakshita, what is your qualification?
it's a Bachelor of Computer Applications.
BCA.
Yes, sir.
When you completed?
Sir?
When you completed?
It's a
What is your output? Yeah, when
2019.
you got your output? 2000?
19.
2019 till the date means it will be around 5 to 6 years, right?
Yes, sir.
If we start placing for a candidate of 5 to 6 years of experience, you are not having a knowledge on 5 to 6 years of candidates. Getting my point? When you are saying Kubernetes concepts, you are saying Kubernetes architecture, difference between those that this is this a concept. I am getting background noise from you, Rakshita.
Yes, sir. There's a vehicle passing.
That's what I'm saying. You go on mute when you're speaking. You can unmute and speak.
Okay, sir.
Okay, Rakshita, you should listen carefully when we start placement of 5 to 6 years of experience for you. You are unfit to this because when you're saying your statement only, you are saying when you are aware of the Kubernetes concepts, architecture, and difference between deployment and those, there are a lot of things, and you need to explain the generic statement of Kubernetes when you're saying, right, Rakshita?
Yes, sir.
Then Okay, then you are aware of complete concept in Kubernetes, correct?
Yes, sir. Not complete. I will try to answer, sir.
Not complete. What do you mean by that?
So it doesn't mean that I need to go through.
Okay, you are aware of Git, right? Git is very basic tool, correct? How do we check the remote repository? Have you joined yesterday's Q&A?
Yes, sir.
Ah, tell me, how do we check the remote repository?
I Git. Okay.
Okay, we'll have a discussion on other concepts. Okay, Rakshita, go on mute here. If you're
Yes,
not
sir.
speaking, you should be in a mute. You don't know how to speak also, and you have a communication problem. Communication in the sense, whatever we ask, you will understand something and you will explain something. So-called communication, I observed, and you were not even clear on any of the concept that you understood. That is for sure. You are simply, you're attending sessions for the namesake. What I understood. Even though when you attend the sessions, even when we cover the concepts, even if you're not able to answer, then it is waste of attending sessions here. Rakshita, you can talk to Swami and get what you want, and then you can attend. Clear? Okay. So let's have a discussion on remaining concepts in Terraform. Rohit, have you learned those concepts? You were not there, right, yesterday?
Yesterday, yeah, I have to go through. After this class, I will go through. I just came home today morning.
Same for you. You need to understand concepts, whatever we covered when you are not joined, and you need to
Okay,
work
sir.
on that.
Okay, sir.
Okay, let's have a discussion on Terraform automatic unlocking and manual unlocking. We call it as. Okay, so did I share my screen? No, right? I'll share. I'm so sorry. Able to see my screen?
Yes.
Okay, so let's have a discussion on Terraform automatic unlocking and manual unlocking. Okay, so we are aware of state locking, right? So where we do the state lock when we defining the state file, right? So that Terraform automatically do the unlock, and uh, if it is stuck in between, we do the manual unlocking. So what is this automatic unlocking and manual unlocking? Basically, we do interact with the state files. Okay, state lock. So we do lock the state file by defining a parameter called terraform lock, right? So you might aware of this, right? I'm asking you guys only.
Yes, sir.
So terraform locks means this state lock will do interact with state file to avoid the conflicts or to avoid the multiple resources will get deployed into the Terraform environments. So called the state locking, right? Correct, right?
Yes.
And we do avoid the corruption of the infrastructure. Okay, now when we are talking about the Terraform automatic unlocking and manual unlocking, and manual unlocking we also call it as force unlock. Okay, unlocking means we are unlocking the key of the state file. Okay, so what is mean by this automatic unlocking, and what will happen inside the Terraform environment when we deploy the resources, when we create an infra. Okay, so in the automatic unlocking, so when we run, right, so whatever the infra that we wanted to create, and whatever the plan we need to add it, or when we need to remove it, we do run Terraform plan to. So whenever we run, basically whenever we run Terraform plan or Terraform apply, or when we want to remove, we do run Terraform destroy. Okay, so during that time, Terraform automatically acquires a state lock on the state file. That means, so when we are running a Terraform plan, apply or destroy, Terraform automatically it will unlock the state file. That's what I'm trying to say here. Okay, so see, when we start running apply, after your all config files that you have defined, your main.tf is ready, your variables and output.tf. When we start running Terraform apply, okay, Terraform automatically, so called the automatic unlocking, the state file will unlock automatically, right? Terraform.tf state, that file will automatically unlock it. Okay, by default it will happen automatically. Okay, so once that command finishes, what is the command? Terraform plan. Once we finish the Terraform plan, the output that we got, and once we execute it, okay, Terraform will unlock state automatically. So this will unlock it. Means whatever the edit or update we wanted to do, we can do it, but during the command running time between 2 to 3 seconds, right? So it will take some time to execute the Terraform plan, correct? So Terraform will unlock the state file, unlock the state, we call it as, okay, state unlock, and it will do automatically in the automatic unlocking. Okay, and basically the automatic unlocking, we use the safe mechanism in Terraform. Okay, instead of doing it manually, so we prefer the automatic unlocking, right? So that defines the automatic unlocking. So I'll give a statement. You were able to understand the statement?
Yes, Sandeep.
What about others?
Yes, sir.
Yes.
I understand.
Guys, I just wanted to ask, who is this Veerbhadra? Who referred? Any idea?
No.
No, sir.
This guy was joining right earlier. Some guy, Veerbhadra.
Yes, he was joining previously.
Yeah, he was joining, right? He is
Yes.
not joining nowadays, right?
Yeah, he's not joining.
Okay. Okay, so I'll give a definition for the very first, which is Terraform automatic unlocking, and manual unlocking. Okay, so manual unlocking, basically we call it as force unlock. See, this automatic locking and automatic unlocking and manual unlocking will deal with the state file. You need to keep in mind. Now I'm gonna give automatic unlocking. Okay, so what this defines, as I already explained, so when we run the terraform plan or apply or destroy, terraform will automatically acquires a state log on the state file. It will happen automatically. We are not doing manually here. That's why we call it as automatic unlocking. Automatic unlocking for what? State file. So what is your state file? Terraform.tf state. That will create now that we Terraform will automatically unlock it. Okay. So when we finish the command of terraform plan or apply or destroy, so even though if it successfully run or fails, even though when you are command may fail, when you are in a wrong configuration, it will fail, right? Terraform will unlock the state automatically. Why? Because if it fails, you need to modify, you need to provide the right configuration, then your state file. So when you are in a state file unlocking, you can modify the infra, correct, right? So that is the reason. So automatic unlocking in the terraform, it is safer side. That's why automatic unlocking will happen in state file. Okay, so I'll give a statement here. So when we run terraform plan, apply or destroy, terraform automatically acquires a state lock on the state file. Okay, that means so it will automatically unlock it. Let's keep it here. Okay, so that means automatically it will so acquires a state locking on the state file. So when we run terraform plan or apply, so the terraform automatically acquires a state locking on the state file. This will happen in automatic unlocking. Okay, and the second point, so once the command finishes, okay, so once the command finishes successfully or fails, means once this, see, when you run terraform plan, it might, when your configurations are good, it will be successfully, right? If your configurations are in a wrong path or maybe some variables are you missed, it may fail, right? We may get anything when you run a terraform plan, right? So that is the reason once the command finishes successfully or fails, right? So terraform will unlock the state automatically. Okay, terraform will unlock the state automatically. Okay, so now the third point, so we prefer the automatic. Okay, so automatic unlocking is the safe method or mechanism in terraform. Why? Because we don't want to run it manually, it should happen automatically. You should not touch the terraform state. See, when we are speaking about terraform state, it should be always use terraform state file only. Okay, that is about the automatic unlocking, right? And there is one more called manual unlocking, right? Then how do we get to know this manual unlocking and what do we do with this? Right, so manual unlocking, we also call it as force unlock. Okay, so I'm gonna write here manual unlocking, we also call it as force unlock. Okay, so what do we have? What do we deal with this? Okay, so now in the force unlock, so if the terraform crashes or your infra might be crashed, might be that infra is not working properly, okay, or the process is killed, or if the network is down, might be your backend, remote backend in the sense where you store your, where you keep your state file in your S3 bucket, so called the remote backend. That during that time you will get a timeout, remote backend timeout, right? That may not be released, which means what will be released? The state locking will not be released, right? So when it is happening, see, obviously this unlocking will happen automatically, right? So during your infra is crashed, or might you have killed some of the process automatically, or network might down, or your remote backend having some timeout issues, okay, the state may not be released. Okay, so in that case state remains stuck in locked mode. Okay, so it will not happen unlock automatically that time. So when your infra is in crashed, or when you kill some process, or are there any some network issues, or might be your remote backend having some timeout issues, during that time during that time the state okay, the state remains stuck, right? So that time automatic unlocking will not happen. There might be a stuck mode. Okay, that time we use a command called force unlock. Okay, there is a command to do manually, that's why we call it as manual unlocking. Okay, so once you found your state lock is not happened automatically, we should do it manually, so called manual unlocking or force unlock. Getting my point?
Yes.
Okay, so I'll give a statement here. So if the terraform crashes the process, sorry, if the terraform crashes, okay, the process is killed, okay, and if the network down, or remote backend timeout, remote backend timeout, the time the state may not be released, right? So the state may not be released. Okay, in that case state remains stuck, right? Stuck in locked mode. Okay, so I'm gonna give the third point. To overcome this issue, we use the force unlock. Okay, so we use the force unlock, and the command below, I'm gonna give the command here. So terraform force unlock followed by the lock ID. Okay, so you will get lock ID from your output only. Okay, so it gives the error saying stuck, the info error. Okay, so when you are, when you're running your pipeline, or maybe when you're running in manually, you will have the error. You will get some info saying the ID, the terraform is locked due to some ID. Okay, so you will get it from your workspace itself. So you can pass that ID here so that you are doing unlocking manually. Clear with this? By running
Yes,
this
clear.
command terraform force unlock followed by this lock id you will get it automatically from your output when you start. Whenever there is an error, it will give along with your lock id. No worries on this, but just you need to run force unlock to do the manual unlocking. Okay, so if there are any these issues, terraform crashes or process killed or network down or remote backend as in timeout issues, that time terraform automatic unlocking will not happen. We'll have to do it manually, so called force unlock. Okay, now you might get doubt here, right? So when you do the force unlock or manually, even though if it is not worked, what you will do, right? We need to think on the fixing the issue, right? The perspective, right? We need to, so even though if you do manually at the force unlock, even though it did not work, what will have to do then? How do we fix it? We need to think on the ground level, right? Even though when you run this, you got the lock id and you ran just you ran this command to unlock it manually, even though you are getting the same error, right?
We are already forcing it, right? Already we are referring.
That's what I'm saying. Even though when you do force locking,
Uh-huh.
so when you have the robust infra in your organization,
Mm.
when you do force unlocking also, you might fail in the manual unlocking.
Okay.
So what we need to do as a plan B, we should have plan B, right? The options that we need to fix it. So from the debug error, you will get the info, the so on ID, the lock ID, you get stuck and you will have to move forward. You will run terraform force unlock, even though if it is stuck, what you need to do. Even though when you force unlock fails, we need to think on that perspective, right? See, it will not happen very rarely, but if it happened, unlocking, when you do terraform unlock, terraform force unlock, even though it did not unlocking it, what is the plan that you will have to do it? Any idea?
We can reconfigure like terraform init. Is that work?
See, when you reconfigure, you need to destroy your, see, you need to understand you ran already the terraform plan, apply or destroy, right? You have already ran init plan and apply, correct?
Yes. Yes.
This terraform info is already created and you will have the state file already created. Again, when you run terraform plan, you will have the terraform previous old is in backup. The existing one when you are applied, you will get the another state file. Again, we'll get conflicts, drift, right?
Yes.
Terraform drift will happen, right? And even though do it from scratch is fine, but we need to identify, instead of doing it from scratch, we'll have to fix it in the process itself. So how do we do? We'll have to identify the active process first. Okay, active
So
process in the sense where we store, see, every environment, every terraform will have lock.info, right? We should check the logs first. Why it is locked? Every terraform environment will be having .log.info. That info is having what is this id, along with this id, and what the process is running to lock this process, in the sense your where it went, your process, so on process is running in backend. That is the reason the force locking is not happening. Manual force lock is happening, or it will show from the error logs, terraform crashed, so on this environment, and we need to fix it. And if the network down or if the remote backend timeout, that .lock.info is having all the logs that we need to check, and we need to check the active process first. Okay, and also we need to verify the backend, remote backend permissions, whether it will be able to fetch in the logs or it will be able to push your terraform state into the remote s3. When you keep in your aws s3 bucket, right, your s3 bucket will keep our state file in s3 bucket, so called, we call it as remote backend, right?
Yes.
We need to check the communication between in our locally and the s3 bucket which you stored your state file. That connectivity, the permission we need to check, right? And similarly, when we have this lock.info locally, similar kind of file, we need to check the logs and we need to identify the process basically, and that we need to remove it. Okay, the cache, and manually delete the lock entry. Lock entry in the sense the remote backend.
Okay, we want to edit the file directory itself and the
Not the state file,
not the log file.
lock.info.
Yes.
That the entry, the remote backend entry, we need to remove it. First, initially, you need to check the permission manually, whether we are able to get that state file is happening. When you run your all Terraform infra, you will get automatically created with the terraform.tf, right? TF state. We need to check whether we are able to keeping it in AWS S3 bucket and we have the right permissions to access it, and if the communication is working properly, right? And we need to check .lock.info locally. The file is, that file also will create automatically, and we check the logs and we identify the remote backend section in the, see that log will be having everything, right? We need to only check the remote backend, right? And also we do backup, and whenever it needs, we repair the state file. See, everything it runs in the state file only. That we need to do it. So even when the force and lock is not working, basically the manual process. So it should not happen from the pipeline always. So by running the pipeline, when you get a state lock or this, when you get a log from force unlock and stuck, the info below, you will get a lock ID. That .lock.info will be having that lock ID. You getting my point?
Yes, Anil.
Are you guys able to understand or confused here?
No, able to understand.
No, I'm getting.
Okay, so I'll give a statement here. If the terraform force unlock fails, so what we need to do, we need to check the active process, okay, and verify backend permissions. This is a brief statement. Okay, we need to check these things. Okay, so we need to verify the backend permissions and check the .lock.info log file and remove it if it is required. Remove it in locally, and we'll remove that. Okay, and the fourth point, so manually delete the lock entry of what? Remote backend. Okay, in the .lock.info, we do delete manually the lock entry of remote backend. Your state file entry in the .lock.info, it might have the permission issues when it is communicating it with the remote backend. We need to delete manually in the .lock.info file. Okay, so if we do this for process, we might have get achieved with the, even though when the terraform force unlock will not work, we'll have to check on this, and we need to do some process. This is manual process. Clear with this?
Yes.
What about others?
Yes, sir.
Rakshita, is this clear?
Yes, sir.
Okay. Let's move to the next concept in Terraform. That is, so how do we handle secrets in Terraform? Right. That let's understand the understanding level of uh, the secrets handling. Right. So we do have, you might aware of the environment variables, right? So we export the variables, and that variable we're gonna call it in the uh, config files, whatever the script that you create, whatever the uh, bash you create, or Python or Ruby, any language script that you create, you will have the environment variables, right? Export those variables, and we do call that variable. Whenever you call that variable, you will be picked with your credentials, right? So that is a way, that is a one way that we define the environment variables in Terraform. Also, the other ways, we do use the secret managers. Okay, suppose if you are in a AWS environment, so we use AWS secret manager, okay, to handle the secrets in Terraform. Similarly, when you are using Azure as a cloud, we use Azure secrets or service principals in Azure. Okay, so currently we are in AWS, so we do use the AWS secret managers. Okay, each uh, concept we do have the template, and we'll have to define secrets, and we're gonna execute our Terraform templates. Okay, so now I'll give some brief notes. Okay, secrets handling in Terraform. Okay, the very first, so we use the environment variables, right? The very first one we discussed. Okay, so environment variables, how it works. We do use so how this environment variables look. So we'll have to do it export. We do the export, right? Export. Let's say if I want to have the DB password that wanted to be exported, so Terraform. So I'll give this as var DB password, right? This I'm exporting it to some password called DB at 123. Okay. Okay. Now, how do we call this in our Terraform template? Right. We do export of some DBs. Might be any other DB. The password is this. And how do we call this in the how do we handle this in Terraform environment? So we start the template called variable. Okay. So what is our variable? DB password, right? So we'll copy this. I'll put it in double quotes. Okay, and open a brace. There should be two space. Okay, the type that I'm gonna give it here is string. Okay, so why I'm giving here is a string, the variable is string only, right? DB password. It is not in a numeric way, right? That should be in a, that's why the type is string. Okay. Now I'll give one more statement here, the one more line, so called sensitive. Okay. So if I provide sensitive here, true, so this helps. Okay, sensitive, when we provide true, this helps in the Terraform environment. It will not show up, means this password will not be show off in your pipeline or in your local when we provide sensitive true. This is the inbuilt feature which is developed by Terraform. Wherever you use sensitive true, when you used any confidential data, maybe password, tokens and all, you will not be seen. You will get the output as like this when you deployed your Terraform templates. When we use sensitive true. Okay, then I'm going to close this brace here. Okay, so the variable, see here I used the environment variable as DB password. That variable I'm going to call it here is this, and the type of the variable that I used as string and the sensitive true. When you deploy this variable in the variable.tf, it will pick your DB password and it will get deployed. This you're gonna call it in your variable, right? Variable.tf. It's a one way of calling the secrets in Terraform. Getting my point?
Yes, but the general suggestion is not to store in the Git repository like these kinds.
Yes,
Right.
and even that's what I'm saying here. Give me some. You should have some time to give info.
Okay.
Okay, so this we use passwords or username, maybe any token. We will not keep it. This is not the safer side. But when you are working in your workspaces, right? When you want to develop some info, when you are in a dev workspaces, you will need to develop. See, we need to handle the secrets in terms of POC and in terms of production. When you are deploying your infra, we need to do it in dev workspace. Then it will move to the QA and prod. That time when you are in a dev, we use export variables because we need to handle the secrets. We cannot handle directly in external library called AWS Secrets Manager or from Azure State, what to call, Azure Secrets or Azure Service Principles, we call it as, right? So you wanted to deploy immediately. So we use some exports variable and that we can handling it. This is the one way. Okay, and even it is not safer side to handle the secrets, even the token and the password, but we are not pushing it to the remote. We are not providing this as a best practice. But for R&D, when you want to deploy immediately, we use this export variable to just to check your infra is working or not. This is one way. Okay, the permanent solution, always we go with the AWS Secret Manager. Okay, so the second method that we're going to use, see, this is for a temporary, for workaround. We should also know this, right? That is the purpose of explaining here. We use export variables as a temporary to check your immediate infra is deployed and you were able to create it. Okay, this is the one way. And the second way, the permanent solution, see, when it is working, you will have to look for the permanent, the long-term support, right? And that should be legally, right? This, we cannot use this we cannot store this in our remote, or we should not keep the secrets, token, passwords and all this way. It should not be exposed. Okay, that is the reason we'll have to go with AWS Secrets Manager. You are aware of this AWS Secrets Manager?
Yes.
We do create the passwords in the username and passwords in the Secret Manager as a best practice, as a best method with the long-term support for your CI/CD pipelines. Even when you go and create manually or automatically, when you deploy the template, it should create it should pick your AWS from the AWS Secrets Manager should get deployed. We should know both the way that we're handling the secrets, right? This is just a workaround for a temporary method. For we'll have to look for the permanent solution, which is AWS Secrets Manager. Okay, so as I said, AWS Secrets Manager. Okay, before moving to that, Rohit, any questions now?
No, no questions.
So that's why. So we need to wait until the statement completes. Wherever you go, you need, at least when somebody is asking questions, you need to, you need to understand the complete question, then start asking your questions or start
Okay.
asking your doubts. Okay. Now, as I said, the permanent solution, the permanent way of handling the secrets, which is AWS Secrets Manager. So also we call it as external secrets manager. External secrets manager. Okay, then how do we handle this AWS secrets manager, and how do we write our terraform template, right, to handle the secrets, right? Let's say you have the secrets created of your or maybe might be any DB password that you created in AWS Secrets Manager, that, and how do we call that, right? So we'll start with the data. Okay, so I'll keep this way. I'll start with the data of your secrets manager. I'm gonna call your our AWS Secrets Manager, AWS Secrets Manager, and the secrets version that we gonna define it here, and what is the which secret that we created for DB, right? See, this is the secret name that you created for DB, right? And I'm gonna call the braces. I'll open the braces here and give a 2 space and the secrets ID. Okay, so each and every secrets you will have ID, right? So you will get the ID. So the ID that say like you might look the ID like this. Okay, you need to point the secret ID and close the brace here, and similarly the output you should get DB password, the DB password as, okay, give a 2 space, the value it should print, right? Value it should print this, right? Data with password. I'm gonna remove this. Okay, the output it should print data dot AWS Secrets Manager secrets version, or let's remove this version first. So this is the secrets that we created for DB. Okay, in our secrets manager, AWS Secrets Manager, and even I'm gonna define it here as sensitive is true. Okay, so when we define this, we will not get printed the value that we created in secrets manager. Okay, and I'm gonna close the braces here. Okay, see, say like you have created AWS Secrets Manager as a name called AWS Secrets Manager secrets for a DB, for some password, DB password. See, the value of your password is this. This you kept it in AWS Secrets Manager, and the name of that you given here, and the secrets ID you pointing here. So from these two, it will pick the DB password and it will move forward to deploy your infrastructure. And to print the values, you will have to use value data.aws secrets manager. It will print your secrets ID only, or maybe the secret name. It will not print your password, the DB password. And even though when we more clear, when we provide sensitive true, it will not print the DB password when it pick from the AWS secrets manager. Okay, so we do prefer this method as a best practice, and long-term support. Okay, this is provided by AWS. Okay, clear with this? I'll give it here.
Yes, clear.
Okay, so AWS Secrets Manager is a feature or the service which is provided by AWS. We do create the secrets in AWS Secrets Manager, and we do call the name of the Secrets Manager and the ID here, and the output that we should get, the value and the sensitive as true. You will not get be displayed the password that you used. If you want to see, whenever whoever creates the AWS Secrets Manager, only he can set that password. Rest of the guys can join later after setting this variable. Nobody can see this password, even though if he is admin also. That is the feature which is providing from the AWS Secrets Manager. Okay, that we prefer as a permanent solution to keep our infrastructure safer side and to handle secrets in Terraform. Right? So either a cloud we need to work, either AWS or Azure. In Azure, as I said, we use service principals or key vaults, we call it as, to store. Instead of AWS Secrets Manager, we use key vaults. Okay, that we're gonna use, and here we point the key vault name and the password that you created. Either it's for, it might be for DB or it might be for your any password. Okay, we do provide the secrets ID here, and we call that output should print this way instead of printing directly the password. Clear with this?
Yes, sir, clear.
Any questions
Yes,
and
sir.
any doubt here?
No questions.
Okay, so if not, let's move to the next concept in Terraform. Okay, so the next concept, that is Terraform lifecycle. Okay, so what do we deal with Terraform lifecycle? And what, let's understand this lifecycle first, then let's explore more in Terraform lifecycle. Okay, so we also call it as Terraform resource lifecycle. Okay, Terraform resource lifecycle in the sense, so we should have the resources defined, and there are some life cycles that we need to add it. The Terraform resource life cycles or Terraform resource lifecycle rules. Okay, that rules has been set from the Terraform lifecycle that defines how these resources are created or how these resources are updated, or how this resource, the infra that you created, is getting destroyed. Okay, that we will configure using the Terraform lifecycle block inside the resource. Okay, so there are some Terraform lifecycle block in the Terraform configuration, and that defines the how these resources are getting created, how these resources are getting updated, and even it is getting destroyed. Okay, that we will configure using the lifecycle block. Okay, so I'll give a sample template here, and we also explore some of the life cycles of Terraform and how do we incorporate that in our Terraform templates. Okay, so I'll give a definition. See, Terraform lifecycle is basically, we do have the block called lifecycle block. There are some, we use some terminologies to implement our infra, create it or to update it or destroy it. That we call it as Terraform lifecycle. Clear with this statement? So I'll give a statement here. Okay, Terraform lifecycle. Okay, so Terraform lifecycle rules defines, okay, how resources are created, or updated, and destroyed, that we will configure. Okay, that we will configure using the lifecycle block inside a resource. Okay, we do have the lifecycle block in our configuration, and sorry. So we do have the lifecycle block in the Terraform configuration that we define the configuration. Inside this configuration, we do define the lifecycle block. We do set some rules, okay, to create how these resources are getting created and then updated and destroyed. Okay, that we will configure using the lifecycle block inside the resources. Okay, so to make you understand, I'm gonna write the sample Terraform configuration with the lifecycle block in Terraform. Okay, so that you will be able to understand this lifecycle block and what are all the types of life cycles that we used in the Terraform configuration. Okay, so I'm gonna give here. Okay, lifecycle block in Terraform. Okay, so I'll start with the resource. Okay, the resource, which resource that we wanted to create or update now, say like AWS instance that we are creating, right? And let's write it in double quotes. Open up brace, give two space. Let's start to create AWS. We need some info, we need some input, right? So what are those input? We need AMI, right? Amazon machine image, right? So under AMI, we do provide the AMI ID, right? So what is that AMI ID? Let's say this is the AMI ID, okay? And when creating AWS instance, we should have the instance type, right? So instance type is, let's say, T2 micro. Let's create this T2 micro, right? And soon after defining these parameter, when creating your AWS instance, we do start life cycle here. Okay, open a brace. This is the life cycle block. Give a two space. Okay, here we define the life cycles of Terraform. Okay, so what are those life cycles? I'm gonna write it now. Okay, create, before, destroy is one of the life cycle of terraform. I'll keep it as true. Okay, and the second life cycle of terraform, which is prevent, destroy, I'll also keep it as true. And the third life cycle that I'm gonna use it here is ignore changes. Okay, so I'll give it as, I'm gonna write it in square brace, which is stacks. Okay, and close my, I'm gonna close my life cycle here block, the life cycle block, and here I'm gonna close the resource block. Okay, see, terraform life cycles are the parameter or rules defined, terraform lifecycle rules defined in resources, how the resources is created, updated and destroyed, that we will configure using lifecycle block inside the resource, right? So what is our inside, so what is the statement saying inside a resource? Currently our configuration is saying the resource block is creating an AWS instance. To create, we need AMI, Amazon Machine ID, and the instance type, right? For these instance creation, how this life cycle that we need to provide, there are the life cycle rules, which are these: create, before, destroy, prevent, destroy, and ignore changes. These three are the life cycle rules of Terraform configuration. This we need to write. This we call it as life cycle, Terraform life cycle inside the resource block. Is this clear? The understanding level is clear?
Yes, it's
See,
clear.
these only we call it as life cycles of Terraform. Okay, so create, before, destroy is one of the life cycle rules of Terraform, and prevent, destroy also a life cycle of Terraform, and ignore changes is also a Terraform life cycle. All three I have written in a single configuration file. Right. Now, how do we learn this? How do we, what are all the types of life cycle argument that we use? Let's explore on this. Okay, so I'm gonna give here life cycle arguments. Okay, so what are arguments? Also we call it as types. I'm gonna give it in bracket, types. Okay, so what are the types of life cycles that we use? Okay, so I have already given here create, before, destroy, right? So what is this create, before, destroy? How do we use it? Why do we use this life cycle? Okay, this is one of the life cycle of Terraform. Okay, the name itself is saying create, before, destroy. Okay, so say suppose when you have the Terraform infra that you wanted to destroy it, right? That means you have deployed the wrong path, and might be you created an instance, instead of creating T2 micro, you have created T3 nano or T2 nano that you wanted to destroy it. Means you are destroying when you're not in a need of infra, right? That time we use create, before, destroy. That defines, okay, this life cycle ensures, okay, when creating a new resource, okay, it ensures a new resource is created before the old one is destroyed. Getting my point? See, this name itself is saying create, before, destroy. This life cycle, when we used in our configuration, this will create, this ensures the new resource is created before the old one is destroyed. Getting my point? Okay, so I'm gonna keep the points here. Okay, it ensures a new resource is created before the old one is destroyed. Okay, see, whenever you use this create before destroy as a life cycle, okay, this ensures, I'll give this way. Okay, so it ensures a new resource is created before the old one is destroyed when you use create before destroy as a life cycle, as one of the life cycle. Okay, and similarly, what was the benefit of this create before destroy life cycle? It helps to manage resources like EC2 instances or your load balancers. It will manage easily by avoiding getting downtime with EC2 instance or your load balancer for the resource. So it will avoid if your load balancers are getting down or if your EC2 instances are getting down. This will avoid by this Terraform lifecycle. Getting my point? Okay, so I'll give a statement here. It helps to manage resources like EC2 instance, load balancer. Okay, and we can avoid the downtime for these resources. Okay, so if there are any downtime for EC2 instances or might be load balancer, so we can avoid the downtime when we use create before destroy lifecycle in the Terraform environment. Right, now how do we write this? How do we use this create before destroy as a lifecycle in the resource block? Okay, so I'll give a sample template here. Okay, so I'll give it as life cycle, open a brace and give two space, just write simple create before destroy as a life cycle. I'll keep it as true. Okay, and let's close this rule, which is create before destroy. We are closing this by closing it in a flower brace. Okay, so we're gonna define the life cycle this way. That's what I have used all three in a single resource Terraform template. Clear with this?
Yes.
Okay, and the second life cycle argument or the second type, which is prevent destroy. Correct, I have used prevent destroy here, right? The name itself is saying prevent destroy. So what does this prevent destroy? Okay, then how do we define this prevent destroy? See, the name itself is saying prevent destroy, means it prevents Terraform from destroying the resources. Okay, if you need in the Terraform infrastructure to be up and run, and until and unless you create the new resource, you will have to prevent the destroy, prevent the infrastructure from destroying the resources. Okay, when we use this lifecycle prevent destroy in our configuration, Terraform configuration, so it prevents Terraform from destroying the resources. Okay, and also it helps in critical resources like production databases, right? So whenever we are using the huge databases, or when we use the huge your Postgres or huge SQL database, So it helps this life cycle, one of the life cycle helps to keep it in the critical resources before destroying. I mean, it prevents the destroying. Okay, so I'll give a clear with this statement. It prevents the destroying the terraform when the resources are getting destroyed. Okay, it basically prevents it. Okay, so it prevents terraform from destroying the resources. Okay, and similarly we do have, it helps in it helps in critical resources like production databases. Okay, so it acts as an critical resource like in production databases. So when we use prevent destroy as a life cycle, so it prevents by destroying the terraform infra. Okay, so how do we write this? How do we write this template? So I'm gonna define here terraform lifecycle, open a brace and keyword 2 space, and write this prevent destroy as a life cycle here and keep it as true. Okay, and close the brace here. Okay, clear with this prevent destroy? See, when you are saying about the life cycles in Terraform, it is different. See, when we are thinking on the life cycle perspective, here we do also call it as life cycle arguments or life cycle rules, we call it as in Terraform. So these are all the life cycles we use in the Terraform to have a robust infrastructure, or it helps to manage dependencies and we can avoid the downtime, right? So here I have given one of the feature of create before destroy, right? So we can avoid the downtime, right? So when we use some of the life cycles from Terraform, we can also avoid the downtime of the resources, which is EC2 instance or maybe your load balancer or might be your EKS, which you host it, right? The resources that you created from cloud. That's the reason we use lifecycle arguments or life cycles in the Terraform environment. Okay, clear with this? Okay, let's have the third life cycle, which is ignore changes. I have used ignore changes, right? So what is this ignore changes? The name itself is saying ignore changes, correct? So this is basically see, this is basically to ignore some specific changes during updates. That's it. Okay, whenever you want to ignore it, you will have to ignore, in the sense you'll have to ignore some of the builds, right? Jairam, you have ignored some of the builds when you want to push to remote, right? In Git, we use .git ignore, right? You have a build copy in your locally and you will have to, we will keep it in .git ignore when you want to ignoring some of the builds which I wanted to push it to remote. Similarly, we use in Docker .git docker ignore. Whenever you want to ignore it in Docker, you will keep those files in the .git ignore, right? Similarly, the changes which I don't want to keep it in which I don't want to track it, I'll have to keep it in ignore changes. I'm going to use ignore changes lifecycle in Terraform. Clear with this?
Yes, sir.
Okay, so why I told you is, remember that we had discussed the recent discussion, you will have to keep it in .git ignore and you need to push that. Okay, that is the reason I wanted to highlight here.
Yes, understand.
Okay, so ignore changes, it helps it helps to ignore specific changes during updates. Okay, and also the second feature during ignore changes. Okay, so it also helps. Okay, so when there is a external system updates. Okay, so external system updates like tags or security rules that you had set. Security rules. See, when we are talking about the external system updates means, see, Terraform is an internal tool. So when it interacting with the other repositories or other tools, we call it as external systems. Suppose if your Terraform is interacting with your GitHub or GitLab is your external system. Similarly, when we're interacting with Terraform to AWS Cloud is an external system to the Terraform, right? So Terraform itself is a system. When it is taking it as internally, if you're communicating with any foreign tool, it think as an external system. That's why always we are keeping it here as external system. Even I gave the statement for one of the statement for external, what to say, where I gave the external one more statement here, right? See, external secrets manager, external system, which means this is the external secret manager apart from Terraform. We are integrating AWS in Terraform in AWS to communicate with each other, saying external secrets manager, which is AWS secrets manager. That we are adding it in our Terraform environment to create a secrets, right? So that when we are always saying external system means either it might be your GitHub, or either it might be your AWS cloud, or it might be your Azure cloud, or it might be your Kubernetes, or it might be your Docker. Okay. So called, we use external systems updates in the sense tag. So where we use tags, we use the tags in the security groups. Okay. So so if there are any security rules which we wanted to change, or the tags that we changed that we wanted to ignore it, right? Because I don't want to keep the tags and security rules to be updated. That is the case, we use ignore changes, because I want the infra to be up and run always, which I don't want to care about this updates, the tags and security rules, right? That case we use ignore changes. Okay, so I'm going to give the similar example here, but instead of prevent, I'm going to give ignore changes as I have used. So most of the parameters or the rules that we use as ignore changes for tags and security rules, okay, which we don't want to keep track from the Terraform environment, which we wanted to ignore it. Clear with this?
Yes.
So basically we are ignoring it. Okay. Clear, right?
Yes.
Okay. And the fourth life cycle from Terraform, there are a lot of life cycles. Yes, based on your requirement, we'll have to use it. Okay. So the fourth life cycle of Terraform, which is replace triggered by. Replace underscore triggered underscore by. Okay. Replace triggered by. What is this replace triggered by? Okay, why do we use this as a life cycle in Terraform, and what is the benefit of using of this replace triggered by? Okay, so replace triggered by means we are replacing something, right? Similarly, when we use ignore changes, we are ignoring something. So whenever we use prevent destroy, we are trying to prevent something, right? Similarly, we create before destroy, we are creating something before destroying. Similarly, we use replace triggered by, we are replacing something, right? What the life cycle says of replace triggered by, okay, it helps to recreate, or it helps to recreate the resources. Okay, so it helps to recreate the resources when a dependent resource or there are some changes. If there are some changes are available, it will recreate the resource automatically when we use replace triggered by as a life cycle from Terraform. Okay, if there are any some dependent resources are available, or if there are any some changes are in the infrastructure, when we use replace triggered by as a life cycle, it will recreate the resource. Okay, clear? So I'll give a statement. So it helps to it helps to recreate the resource, whenever when there is a dependent resource are available. Okay, and also it helps to, if there are any, okay, if there are any changes or updates or updates are available, so that time it creates the resource. Okay, so you were able to understand this replace triggered by. So it helps to recreate the resource when there is a dependent resources available. Say suppose dependent resource in the sense, suppose if you are deploying, if you are creating a DB infra, there is a dependency of your schema, right? The external repository, or the dependency of your table creation, the queries that you wanted to run. That time, if that schema is not picking the right API when you're creating your DB, that time we do use the replace triggered by lifecycle, and it recreate the resource of your database infrastructure. Okay, and similarly it helps. Okay, it helps if there are any changes or updates are available in your infrastructure, we use replace triggered by as a lifecycle. Okay, clear?
Clear.
I'll keep
Yes.
lifecycle as a replace triggered by. So what are all the concepts that I need to keep here? Suppose if you want to have the subnet ID and the security group that you wanted to be recreated, I'm going to add it here, AWS subnet ID, and similarly AWS security group, and I'm going to close the replace triggered by lifecycle is here by square brace, and similarly I'm going to close the brace here. And also suppose if you want to create the schema db schema.id, there might be, if you want to pick the other schemas, you might aware of the schemas, right? When you are dealing with your database, it should call some schemas, the tables, and pick the data from the databases. That time we use replace triggered by as a life cycle in Terraform. clear? Guys,
Yes.
are you
Yes, yes.
with me or is okay? So now I'm gonna give some of the features of life cycle here. I'm gonna list it here. So as I explained, so it helps to manage dependencies and avoid the downtime, correct? And also it protects the critical infra from the accident Okay, then fine. So we'll have a internal call. Let's conclude. Okay, so if there are anything, might be we'll take 1 or 2 sessions to wind up. Okay, let's do that.